So, guys, girls, for the number of you that said, I don't get any of this, I don't see any of them written on the backboard, so that might be because there's not a marker back there, but there was one front. So let's run through these, see how we did. You recall from the other day, we did 1 through 6 in class, and then I wanted you to do 7 through 15 on the rest of them. So let's see how quickly this board can catch up with us. Good. All right. So number 7, you have 1 over square root of 81. What's the trick on this one? Yeah.
Multiply by square root of 81.
No, I don't have to do that on this one.
You don't?
Just square root of the bottom. Take the square root of the bottom. What's the square root of 81? 9. So you get 1 over 9. So if it's already a perfect square, you don't have to root top and bottom. But then number 8, you have 2 over root 11. And root 11 doesn't work, so what do I have to multiply top and bottom by, Summers?
Root 11.
Yeah, root 11, which gives me 2 root 11. Come on. Catch up. Catch up. What is the square root of 121? It's trying to catch up. 11. There we go. So then we get 2 root 11 over 11. Let's see if it catches up. Oh, yeah. How'd that work? So if I multiply a radical by the exact same thing, that becomes the perfect square, which undoes it nicely. Okay? Number 9, I get 4 over root 2. Is root 2 a perfect square? No, so what do I multiply top bottom by? Root 2, root 2. Okay, it's coming.
Just work on the problem.
Hey. Thank you very much. Perfect. So I get if I get this, I have 4 root 2 over root 4. And what's root 4? 2. And then I get, can I reduce these if I need to?
Wait.
Yes.
Yeah,
It's coming.
Yes.
Can I reduce 4 over 2? Does the inside the radical reduce with outside the radical? No. So 4 over 2 reduces. So that comes out to that. It doesn't have to stay as a fraction any longer. Number 10, I get 1 over root 3. Let's clear ink. So 1 over root 3. Root 3 is not a perfect square. What do I multiply top and bottom by? Root 3, root 3. So I get 1 root 3. Is 1 root 3 and root 3 the same thing? Is 1 times root 3 the same thing as root 3? Root 3 times root 3 is root 9. What's root 9? 3. Can I reduce this 3 with this 3? No. Why?
Because
It's root 3.
One's in a radical and one's not. They're not like terms. Okay? Number 11. If you know your perfect squares, you'll do well. Square root of 225 is 15. Okay? If you didn't, you multiply top and bottom by 225. And you'd have to know this perfect square to break it out. Number 12, I have 1 over 3 root 16. That's a 16. What's the square root of 16? 4. 3 times 4 is? Okay. Can I clear? 13. Root Root 2 is not a perfect square. What should I multiply top and bottom by?
2.
You need to go to the nurse, please. Take your stuff, go. Go ahead. What do I multiply top and bottom by?
Root 2.
Root 2 and root 2. Okay, so I get 8 root 2 on top. What do I get on bottom?
3 root 4.
3 root 4. What's root 4?
2.
2. So this would have given me square root of 4. Square root of 4 is 2. I get 3 times 2. So that's 8 root 2 over 6. Can I reduce 8 and 6?
Yes.
Yeah, so I get 4 root 2 over 3. Then number 15, I have 1 over root 2. Root 2 is not a perfect square, so what should I do to top and bottom? Root 2. What's 1 times root 2? Just root 2. Root 2 times root 2 is root 4. What's root 4? 2. Can I reduce this 2 and this 2? No, they are not like terms. Okay? Sound all right? A-okay?
Just
Yo.
so 1 and 2 and 14 and 15 were the exact same problems.
1 and 2 and 14 and 15? Oh, sweet. Sorry.
I was confused by that, so I didn't
It was accidental. It was not on purpose. Okay. So radicals go along with, remember we rationalized the denominator because back in the olden days before we had calculators, it was more difficult to deal with the radical in the denominator. A fraction is the same thing as division. If I were to take a radical into a whole number, that becomes a lot harder than a whole number into a radical as far as division goes. Both of them are both pretty tough things to do, but that's the reasoning behind it, why we rationalize the denominators, okay? So let's have you guys flip on the back side of that page. It's page 47, and it's 16 through 35. What I want to do is I want to walk through each problem. I'm going to do the evens real quick, if that's okay. So problem number 16. We're not necessarily rationalizing the denominator because we don't have a denominator. So what's the square root of 4? 2. So this, if it's a perfect square, take the square root of it. But then problem number 18, again I'm working on just on the evens. Can I have a negative in front of a radical? Or where does the negative fall to make it no real solution? Inside the radical. Good. So can the negative exist outside? Yeah, that just means it's going to be a negative answer. So our answer here is negative. What's the square root of 10? Our square root of 100 is 10. So this negative comes along with the right. Problem number 20.
What was 17?
Oh, I'm just doing the evens right now.
Oh,
Okay. Number 20, I get w to the 12th power. So that changes up things a little bit because I have the square root of a letter. How many w's are being multiplied together under this radical? 12 of them. Yes, you could write them all down, and how many of a kind are you looking for? 2 of a kind. So if you went, and if you see it this way, please by all means do it this way. If you don't, 2, 3, 4. So that's basically what that is. Those w's are all being multiplied together. You're looking for pairs. Square root of that is w. 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 W and w. All the w's come out because it's a perfect square. How many w's came out? 6. So what's the answer? W to the 6th. And there's nothing left inside the radical because they all came out. W. Okay? 22. Problem number 22 I can squeeze here. 9a squared. Well, what's the square root of 9? 3. What's the square root of a squared? A. 3a. Done. Okay. Did I have to write a times a out to figure out that an a is outside? Can I clear? Yeah, some of you might have seen it this way. And maybe I do it that way, but that's fine. It's up to you if you want to do it that way now. 24. Okay. So rather than writing all the letters out, is a to the fourth a perfect square? So if I take the square root of a to the fourth, what do I have left? A to the 2. If I take the square root of b to the 12th, what do I have outside? B to the 6th. Square root of 49 is what? 7. So I get 7a squared b to the 6th. Hey, where did the radical go? It's gone. We had a perfect square in there. The radical is gone. And I know a lot of you are going to make the error. If you have a perfect square, you want to keep the radical. You're like, no, it couldn't all go away. No, it does. If you have a perfect square and you take the square root of a perfect square, the radical's gone. The square root sign's gone. And then 26, this is going to start leading us into a little bit what we're going to work on today. If I have square root of 18, this is not a perfect square. It's not a denominator, so I don't have to rationalize it. But 18 breaks down to 2 times 9. Those of you who are sitting there going, oh, well, what about 3 times 6? You're absolutely right as well. But 9 happens to be the largest perfect square that works with this. So that's 3 square root 2. Okay? So for those of you who are having a hard time with that, and you're like, well, what if I broke this down to this? You're still correct. It's just that neither of these are perfect squares, so then you'd have to break it down a little bit further to get that. Here's my perfect square, right? If I take the square root of that, I get 3, and what do I have left inside? Root 2, which matches that answer. We good so far? Okay. Can I clear? Okay. How do we approach it? Most of you are seeing 9 times 8, yes?
Yes.
Should we do it that way? We can? Let's try it. What's the square root of 9? So this would be a 2-point problem on the test, and I'm taking 1 point off at that answer. Why? What's 2? No? Anyone know why I'm taking a, yeah.
You can break down 8 into 2 times 4.
Yeah.
And get the square root.
Absolutely. 8's breaking down a little bit further, so you get this. So the square root of 4 is 2. That's 6 root 2. So let's approach this another way that some people might see this. You could also see this. And then the square root of 36 is 6. But some of you might not see that right away. You might see this. Square root of that is 6 outside, and you still have a root 2 inside. So there's different ways that you can approach this. Which way is the right way to approach it? Whatever way your mind makes it work and your answer matches mine. Okay? 30. Can I clear this? And again, this is all being recorded, so if you need to go back, please go back. Is a to the third a perfect square? No. So this is the same thing as this. Agree? How many of a kind am I looking for? Square root of that is what? A. is outside. Anything left inside? Done. Crystal, you're right? I see you're right, and I see I just didn't know if you were looking up or not. 32. Let's approach it. How do you want to approach it? Yeah.
9 times 45.
What's that?
9 times 45. I mean, times 5.
9 times 5?
There.
Okay. 5 can't be broken down any further, and 9's a perfect square. I kind of like that one. You might have someone saying, well, what about 3 times 15? Yeah, you're right, but 3 and 15 aren't perfect squares, so I'd have to break 15 down to 5 pairs of numbers. I have 8 of the 7, though, so I have 1, 2, 3, 4, 5, 6, and 7 pairs. How many A's are outside now? 3. What's outside numerically? 3. Square to that is 3. And then I have 8 of the third, because 1, 2, and 3. What do I still have left inside my radical? 5 and an A. And then last one I want to work on from this page. Can I clear? Aye. Some of you are going to say, oh, cool, 12 is the same thing as 6 times 2. And you're absolutely right. If you see it that way, then you have to break 6 down to 2 times 3 and look for pairs. Others of you might see 12 as 4 times 3. And you choose that route because 4 is a perfect square. Okay? Okay? Perfect square. What's the square root of that? 2. What's the square root of this? X to the 10th. Awesome. Okay? The square root of an even number is perfect. What do I still have left inside? 3 and a y. Okay? There's no x's in there because x to the 20th happens to be a perfect square. What's that? Exactly. The pairs exactly break down evenly. I like it. I like it. Y'all feel okay about that? Okay, so multiplication with radicals gets pretty easy. Okay, you could, if you're multiplying two things together, you can just expand. You can multiply inside of a radical and inside of a radical. You can multiply outside of a radical to outside of a radical. You can't multiply inside of a radical to outside of a radical. That doesn't work nice and neat. But if we get into adding and subtracting radicals, so let's say I have 6 square root 2 plus 7 square root 2. Would you feel these would be like terms?
Yeah.
What's going to identify a like term for you? Root 2. So 6 root 2 plus 7 root 2, because I have a root 2 and a root 2, those are exactly the same. These are like terms. So I can add these just traditionally. 6 plus 7 is 13, and then the root 2 comes along for the right. It works like a radical does, or a variable, a letter. Okay, this is the same idea as if I had 6x plus 7x. Like terms gives me 13x. So this works the same way. So we're getting this, for this answer here, where the radical comes along for the right. It's a like term. Okay, but there might be some other times where, can I erase? Tell me if I go too fast. No, don't mean to. But let's say I had root 72 and root 2. Like terms or not? They don't appear to be, do they? Does everybody agree they don't look like terms? So right now I cannot say this is 11 root whatever. I don't have like terms. Can I break root 2 down to anything smaller? Can I break root 72 down to anything smaller? What? 9 times 8, I like it. So let's choose that route. So let's take root 72. Root 72, and let's break root 72. And let's break that down. So 9 times 8, which is 3 root 8. Is that done? No. What breaks down? 8. What's the square root of 4? 2. What happens with the 2 outside? By 3. So this is going to become the same thing. This is the same thing as 6 root 2. Because of that. What else did I have outside though? So this is 30 root 2 plus 6 root 2. Do we have like terms? What's the answer? 36 root 2. So when you're adding it, the radical won't change. It's like a letter, okay? All right, so hang on. Let's make sure we can make this work. So I just took this right here, and I'm able to say that is the same thing as this. But then I had that 5 that also had to come along. That's why that became 30. I had to multiply those. So if you're adding or subtracting them, check to see if your radical can break down. If it can, then go a little bit further with it. What if it can't break down? Do you just leave it blank? So break your problems down as far as possible. Okay? Break them down as far as possible. If it won't break down any further, that then becomes your answer. It would be okay to have an answer of like 2 square root 3 plus 3 square root 7. Totally appropriate answer. And it's actually something you would see as you further yourselves with math, a class called trigonometry. In my opinion, trigonometry is my favorite class. I love it. It's the biggest puzzle of math classes that there are. And when I say puzzle, they truly are puzzles. Okay? And I think they're just great brain exercises. So if you get the opportunity to take some sort of trigonometry class, I highly recommend it. And I know some of you are sitting there going, no way, I'd never take that. And I would have been where you were sitting too when I was your age. No way I want to do that. And all of a sudden I got a degree in it, so figure that one out. Can we try one? You work it? Ready? Let's try this. God bless you. I want you to try that one. See if you can figure it out. I will tell you right now as they sit, they are not like terms because under the radical is not the same on both sides. See if you can break that down. Gage, what do you think 18 breaks down to? I like it. Anyone following Gage on this adventure? Preston, what does 8 break down to? Okay. George, 7 square root 9 and 2. Underneath that radical, is one of those a perfect square? 9 is? Okay. Okay. Gage, picking you again. Underneath the second radical, the 2 and the 4, either of those a perfect square? Yes. Which one? 4. Okay. Casey, what's the square root of 9? 3. So that becomes 3. Kruger, square root of 2, or square root of 4, excuse me. 2. Does that look okay so far? Any part of that we can't do? Steve, we can multiply outsides. Okay, what's 7 times 3? 21. And what's 6 times 2? 12. Raise your hand if it looks like we have like terms right now. Take a look around you. Those raising their hands are right. Why is there like terms? Why are they like terms? Cole, why are they like terms? There you go. Root 2 and root 2 are like terms. So now I'm going to add outside. 21 added to 12 is 33. The root 2's just come along for the ride, staying as is. They act like a variable in this scenario. So we're going to distribute these as well. Can I clear this? Let's distribute. Let's say I had square root 3 times square root 7 plus square root 10. I'm going to distribute over the parentheses. What do you think? Because I'm multiplying, I can increase the inside. So what is root 3 times root 7? Root 21. Awesome. Plus, what is root 3 times root 10? Root 30. 21 is the same thing as 7 times 3. 7 and 3 can't be broken down any further, so I think that's fine. Root 30, let's see, I could use 3 and 10. 10 would break down to 2 and 5, so 3, 2, 5. I don't have any pairs there. Is root 30 good as is? Are those like terms right now? No. Can I add them together? I can add them together, and this is my answer. It's done. There's nothing more you can go with. That's like saying x plus y. What's x plus y? X plus y. Good. What's root 21 plus root 30? Root 21 plus root 30. It can't break down any further. Last thing we're going to do, 4-letter F word. FOIL. Mac looks up, oh my gosh, she's going to say it. FOIL! FOIL, FOIL, FOIL. FOIL. You guys remember this FOIL stuff? Let's get bad with this. Okay, if I have two binomials, a binomial, if you remember, is two different terms that are put together by addition or subtraction. And if I have them together, it's just basically just distribute on steroids. So you take your first term and multiply times your first time. So root 2 plus root 5 is? Root 10. God bless you. Outside terms. Root 2 times root 7 is? Root 14. Inside now. Root 3 times root 5? Root 3 times root 7? Root 21. Okay, let's see if we can break anything down. 10 breaks down to 2 and 5. No perfect squares. 14 breaks down to what times what? 2 and 7.
Wait,
no, yeah.
Question. What was the one that said like the 7 goes into the 2 and the 2 goes into the 5? You have like the line at the top. It's like inside the 7, then it goes to the 2, and then it bumps to like the 5.
So what I'm doing is this goes to the first term and the second term. And then I take this and multiply it with this and this. First, outer, inner, last. It's distribute twice.
Okay.
That's all it is. Hey, can I break 15 down? That's the same thing as 3 and 5. Those can't break down. What about 21?
3 times 7.
Can that be an answer? Heck yeah. Can I combine them together? Nope. We are simplified. Does anyone want to know why we use a radical versus a decimal approximate? Any ideas? Any of you heard about this plan that we are going to send people to Mars?
Yes, and they're only gonna like survive for like 30 to
hope they survive longer, but
No, it's something that's due to like Mars's pressure. This was like on the news and they were like joking about it, but it was just like after like 30 days they're just gonna like die from no oxygen or like something like that.
okay.
It's depressing.
Now, if they don't die and they have to live for a while, a few things I've heard. I heard it's a one-way trip as far as technology goes now. So you're on that rocket ship and you're cruising to Mars with 11 of your best friends for the rest of your life.
You better be good
Or until you
friends.
die.
Yeah, or until you croak.
You better be really good.
You better be really good friends. Could you imagine you just broke the orbit of Earth and you start your first argument?
Oh God.
This is going to be a long time. You better figure things out real quick.
It's like a 3-month trip.
Oh yeah, it takes a long time to get there. But if you do happen to get to Mars and all of you happen to survive, and you happen to survive longer than 30 days, you're going to be doing things like communicating with Earth, and it's probably going to take, 7, 8, 9 minutes for your transmission to go back and forth from Earth because it travels about the speed of light, which is great. But then you really can't say, hey, could you tell my mom to send me another pair of socks? What you left with, you got. Unless you can mass produce it on Mars, which that's a little different. You could run out of food. I imagine they have a few things in place that they will try and harvest some sort of
Are they
garden.
gonna try to do like what The Martian did, like that movie, The Martian?
Well, I don't know. I didn't see that movie, but
Did you read the book?
I didn't read the book either.
Oh man, you missed out. That was a really good.
Well, the good thing is it's still unpublished, so I probably could still get it.
Yeah.
So I'll definitely read it. It's on my agenda to read. I'm just in the middle of another book right now.
Yeah, but what he does in like the movie is like
Like he makes a
gets,
garden
he
and
gets
all.
like a tomato seeds. He like starts planting them like a plant as it grows.
I understand. It seems like, I mean, it's a neat thing to approach. And should there be excitement for us going to Mars?
Yeah.
I think so. I think it's pretty darn cool. You know what I'm frustrated about?
What?
So I don't really believe that we went to the moon. But, and this is why. Why have we not gone back to the moon since 1979 if we've gone to the moon?
Alien rocks. I have seen Apollo 18. I know the business
Same.
here.
That's why we don't go. We're
That's a
scared.
fictional movie.
I
but
also
so-
watched. It was like a documentary. It was like, why we didn't go back because it was like there were little alien moon rocks. Plus, we did, and there's a fact that we did bring moon rocks back to Earth, and then we were like giving them to like the capitals, but like something was weird and something, and so when we tried to retrieve all like the moon rocks, they were
I thought I was into
Someone-
conspiracy
someone
theories.
gone.
Reese is all over this stuff. So this frustrates me. If we truly are going to go to Mars, don't you think we should say, let's try and go back to the moon again because it's a little closer?
Yeah.
I mean, 3-day adventure versus 3-day returnable adventure versus 90-day non-returnable adventure.
How long did it take us last time to get to the moon?
3 days.
Oh, all right. So it wasn't that bad.
I mean, we're not going to necessarily
But I mean,
speed
like
things
the
up.
moon is it's so dark. Mars is like all red and stuff.
I don't know. I looked at the moon this morning and it was all white.
Nah, but it's like if you go on the moon, all you're gonna see is like just the Earth in the distance, and you'd be like, oh, that's cool. If you're on Mars, it's like, whoa, there's like sand. It's red. It's pretty cloudy. It's pretty nice.
It actually has clouds.
Yeah, you would actually
It's
feel like you're
actually
on
an
another
atmosphere.
planet. It's not like you're. It's not like you're on like another
It's
giant
not like you're on a
like
big
ball,
rock.
another rock.
So-
orbiting
Oh.
around another.
So let me ask you all this.
You're
If-
actually on a planet, not like a moon that's rotating around.
I understand. Let me ask you all
That's
this.
why they're more
If you had that opportunity to go to Mars and you knew it was a one-way trip, would you take it?
Yes.
Yeah. I
Raise
feel
your
like-
hand.
Raise your hand if you're a yes sir.
I only
Sweet.
think like
All
space
right.
aliens are on like planets, not like on the
We're
planet.
gonna make
so.
a new colony.
And when I'm thinking
Yeah.
of smart,
I heard someone call me. Yeah. Yeah, let me put the assignment up real quick. And so, what I would like you to work on is from worksheet number 22. This is on page 47. I would like you to do the odds. Okay? We just did the evens. Okay? I want you to do the odds. And then worksheet number Worksheet number 23, 1 through 16.
Doing.
And Yana. Okay, I think you guys can get there. I think we could. And you have quite a bit of time, so I bet you if you start now, you should be able to get there. Actually, let's do this. Let's do this. Let's make this 1 through 15 odd. I'll cut that down. Is that right?
Oh, so we're doing all odd numbers for
1, 3, 5, 7. 1, 3, 5, 7 up to 15 here, and then doing the odds on page 47. Sound good?
What?
Yo.
He said last week that